You know, there's a point in our lives as Nigerians where we theoretically say it that whenever I'm 18, I would have graduated from university. When I'm 20 to 22, I would have finished my master's and PhD. Between 23 and 25, I would have gotten a job. I would have bought the most expensive car, bought the most expensive house. Then when I'm 25, I would have met the love of my life and I'm going to be getting married at 25. Then we're going to have our wedding on a yacht. I'm going to probably have it in an aeroplane. You have theoretically said it. Well done. But when you start going through the experiments of life, you realize that all these things you have said do not actually come to reality easily. As you strike, the difficulties in the family, and all of these things can make this thing not to go the way you have planned it. Immediately you want to start preparing for JAMB, you say, I want to score 350. You planned everything well. Yes. But when you start going through the practicals of it, you realize that I couldn't score 350. You planned it, but the experiment didn't actualize the way you want it. Some of you will have to work extremely hard to get such 350. Sometimes the questions you see in exam might not come in favor, and that's why I always pray that the questions will come in your favor. So all of these things are theoretical, but when you go through the practical or the realization of it, you see that it does not really come the way it should be. Now, when you get to university, the first thing you plan is that I'm going to be the best graduating student. You plan it very well. But by the time you start going through classes, the stressful thing, you start meeting friends, you start getting distracted here and there, you miss out on the way. You won't know how all of these things just happen. You have theoretically said it, but you experimentally miss out. So that is the essence of this class. So whenever you want to produce something in the laboratory, in chemistry too, there's what we call an actual yield and there's what we call a theoretical yield. Before I go into the laboratory, I could have talked about by calculations. This is the mass of something I want to get. My assumption is that I'm going to get 10 grams of water in the laboratory from theory. That's my assumption. I theoretically did it that when I mix this reactant with this reactant, I'm going to get 10 grams of water. By the end of the day, when I go to the laboratory and start mixing things together, I did not even get 2 grams. What could have happened? And that's what we are trying to talk about. So theoretically, I planned it that I should get 10 grams. But experimentally, I got 2 grams. So that 2 grams you got by experiment is what we call actual yield. The 10 grams you got by your theory is what we call theoretical yield. You understand that? So now, that's what we want to talk about. When you now get your actual yield and your theoretical yield, you calculate your percentage yield. So your percentage yield is defined as the ratio of the actual yield to the theoretical yield expressed in percentage. That is, we're going to say percentage yield is equal to actual yield over theoretical yield multiplied by 100. So write that down. Now, the next thing you now need to know is that what do we call theoretical yield? So theoretical yield is the maximum amount of product that can be obtained from a specific amount of reactants with complete consumption of the limiting reagents. You know, I already said something from the beginning. By theory, you said that this is what you want to get. So the total amount, the maximum amount you should actually get if you carry out that reaction is what we call theoretical yield. I talk about food a lot. Let's say you go into your kitchen with probably that 2 cups of rice, like I said in the last class. At the end of the day, probably when you are parboiling the rice or you are rinsing the rice, by theory, you know the amount you went in with, but theoretically, you know the amount you want to get out. But at the end of the day, by practice, you have wasted some part of the rice. So it's the same thing here. So theoretically, you know the total amount you should get from reacting a particular thing together. But at the end of the day, it does not give you the actual amount. So now, that is what we call the actual yield. So actual yield is the amount of a specified product obtained from a given reaction. So at the end of the day, when you now carry out your experiment, that yield you get from the experiment is what we call actual yield. And most times, actual yield is always supplied in your question. But by theory, you can calculate that. That's why it's theoretical. Between your actual yield and theoretical yield, think about which one should be bigger, which one should be smaller. You know, by theory, you won't have an error. It is a theory. By experiment, we have error. So that will reduce the amount you are planning to get. So let's solve questions on percentage yield and theoretical yield, and let's understand it better. So the question says that what is the percentage yield of water if 0.90 grams of water is obtained when 29.0 gram of butane is burnt in excess oxygen? So look at it. What is the percentage yield of water? So the first thing is, you know where you are going. I always tell you that's the first thing in chemistry. Where am I going? I want to calculate percentage yield. So percentage yield is going to give me actual yield over theoretical yield multiplied by 100. So the question is that how do I get my actual yield? How do I get my theoretical yield? So now let's see what you were supplied. You were told that what is the percentage yield of water if 0.90 gram of water is obtained. So 0.90 grams of water is obtained. That means that by experiment they have done it. So they got 0.90 gram of water. So that means your actual yield, let me just say W, actual yield is 0.90 grams. So now let's now theoretically think about it. So we will, by theory now, we want to do the calculation. So that's theory. So by theory, let's look at mass of water that should have been obtained instead of 0.90 gram. Shey you get, that's what this part is talking about. What is the mass of water that should have been obtained? So now, what do? You balance the equation. Butane is C4H10 plus O2 to give CO2 plus H2O. When we get to organic chemistry, I'll teach you how to balance this equation. But now we can balance this straight. Since we have oxygen here, then we're going to have 4 carbon here, so you can add 4 here. 10 hydrogen, so you can add 5 here. So that means that now if you look at this, 2 times 4, that's 8 plus 5, that's 13. So there's supposed to be 13 oxygen. So you're going to have, you just say 13 over 2. 13 over 2 is going to be 7.5. So you can say 2 times 7.5 is 13. But you cannot leave it like this. So what do? You multiply through by 2 to have a perfect ratio. So you're going to have 2C4H10 plus 13O2 to give 8CO2 plus 10H2O. So this is the balanced equation for that reaction. So now what do I want to calculate? I want to calculate the mass of water. And you remember from all the things we have been doing, you are given the mass of butane. There's a way we could have done this in very short, but I'm still going with our formulas for now. So if I want to calculate mass of water, you remember number of mole of water is going to be mass of water over the molar mass of water. So I will know the molar mass of water, which we have always done, that's 18. So I can calculate the mass. Then I want to get the number of mole of water. So to get the number of mole of water, I can get it from this balanced equation. So let's look at the mass of, so you are given mass of butane. So first thing is, how do I get the molar mass of butane? So molar mass of C4H10 is going to be 4 carbon plus 10 hydrogen. And that's going to be 4 into 12 plus 10 into 1. And that should be 58. This is 48, that's 58. So that's 58 gram per mole. So now the molar mass of butane is 58 gram per mole. So I want to know the number of mole of butane. Their ratio is 2 to 10. So that means that the number of mole of butane, C4H10, is going to be mass of butane over the molar mass, and that's going to be 29 divided by 58. So what would that give us? So that's 29 divided by 58. So that's 0.5. So that's 0.5 mole. So if you think about it now, this is 0.5 mole. What would this be? That means each mole must have been like 0.25. So if this is 0.5, then what do you think this would be? Then this would be multiplied by 10. That means this would be 2.5. this will be 0.5. You know, the ratio is 2 to 10, right? So the number of mole for this is 0.5, then this will be 2.5 if you check it. So do you understand what I've done here? If this is 0.5, this will be 2.5. Their ratio should be 1 to 5. Shey you get, this is 2, this is 10. That's 1 ratio 5. So this is 0.5 times 5, or you just divide this by 2 so that you get 1 mole of it. Then you multiply it by 10. You just divide this by 2, so that will be 0. So 1 mole of this will be 0.25. If 2 mole is 0.5, then 1 mole will be 0.25. Then 10 mole multiplied by 2, 0.25 will give you 2.5. So now that I know the number of mole of water, I can calculate the mass of water. So the mass of water is going to be number of mole times molar mass, and that's going to be 2.5 multiplied by 18. So 2.5 multiplied by 18, that is 45 grams. So imagine this, 45 grams. So by theory, if this reaction should go well, I should get 45 grams of water. But when the reaction experiment was carried out, they got 0.9 grams. That's a very great error. So now, that means that what is my percentage yield? Percentage yield is going to be my actual yield divided by the theoretical yield multiplied by 100. So my actual yield is 0.9, so that will be 0.9 divided by theoretical yield 45 multiplied by 100. So that would be 0.9 divided by 45 multiplied by 100, and that's 2. So my answer is 2%. So the one you obtain by theory, by saying that if I react 25 grams of this with this, I will get 45 grams of this, that is what is called theoretical yield. But if you actually go into the lab to carry out the experiment, there might have been error. Some of this oxygen might have reacted with something else, and this guy did not react with oxygen completely. So there are a lot of errors that could have happened. There might be presence of impurities here and there. So, and now the percentage yield is 2%. This was an OAU post-UTME question. So let's look at question 2. Now, if you look at question 2, if you solve what we did on limiting and excess reagent, this one is trying to compare two things now. So you have to get the limiting reagent, then use it to calculate the mass of KNO2 before you now calculate the percentage yield. And that's it. We have done that before. So let me just solve this with you quickly. Then you will solve number 3 yourself. So if you are here to watch the videos on limiting and excess reagents, please, you can do to understand this better. So when 10 grams of lead was heated with 24 grams of KNO3, so that means that the reaction is PB solid. I don't need to write that, so not waste our time. KNO3, let me write it to give PBO solid plus KNO2 equals. So now you have to calculate the percentage yield of KNO2. The ratio of everything is 1 to 1 to 1 to 1. So if you want to calculate percentage yield of this, that means you need to, by theory, first calculate the mass of this. Then were you given the actual yield? So they said 3.8 gram was formed. So when 10 gram of lead was heated with 24 grams of KNO3, 3.8 grams of KNO2 was formed. Calculate the percentage yield of KNO2. So if you react 10 grams of lead with 24 grams of KNO3, what is the mass you should actually get? That's what we want to do. So you first calculate the mass of KNO2, then you now calculate percentage yield by using this actual yield gotten from experiments divided by the theoretical yield. So let's do that. So in order to compare their mole, you know, I told you that since their ratio is 1 to 1 to 1 to 1, so what do we do in order to get their mole now? So you're going to first get the number of mole of lead, and that will be mass of lead over the molar mass of lead. So the mass of lead is 10, the molar mass of lead is 207, and that will give us, so 10 divided by 207, and that gives 0.0483 mole. So that gives 0.0483 mole. So the number of mole of lead is 0.0483. So let's calculate the number of mole of KNO3 so that we'll know the limiting reagents, the one that reacted and the one that did not, over molar mass. So now the mass of KNO3 given is 24. So the molar mass of KNO3 is going to be, you should be able to calculate that, that's 3 times 16 plus 14 plus 39. So that's 101. So that's 25 divided by 101. So that will now be 24 divided by 101. And that gives us 0.2376 mole. So now let's compare them. Their ratio must be 1 to 1 to 1 to 1. So now which one do you think is the limiting reagent? The number of mole of lead is 0.0483. That of KNO3 is 0.2376. So now if you compare them, what do you think that would be? This is smaller than this. That means that this is limited, this is in excess, and they must react 1:1. That means if this is 10, this must be 10. If this is 5, this must be 5. If this is 0.2, this must also be 0.2, but this is not up to 0.2. So that means this is limited. And from what I taught you in the last class, I already said the limiting reagent is what will determine everything. So now that means that if this is 0.0483, then this will also be 0.0483, and this will be same thing for everything. The ratio you are going to have is 1:1 all through. So that means I already know the number of mole of KNO2. Now can I calculate the mass? So number of mole of KNO2 will be equal to mass of KNO2 over molar mass. So the mass of KNO2 is going to be number of mole of KNO2 multiplied by its molar mass. So now let's calculate the molar mass. We already know the number of mole, that's 0.0483 multiplied by, so that will be 2 times 16, 2 times 16 plus 14 plus 39, and that's 85. So multiplied by 0.0483. So the answer is 4.1055 grams. So you can imagine, this is the mass you should be getting, but this is the mass you are getting. So by theory, this is what you should have gotten. So if you go to the lab now to react these guys using this amount, then this is what you should have got. But in the lab now, you got 3.8. So that means the theoretical yield is 4.10 and the actual yield is 3.8. So there must have been error somewhere. So now to calculate the percentage yield now, that is going to be the actual yield over the theoretical yield multiplied by 100. So what's our actual yield? That's what we got by experiment. That's 3.8. Our theoretical yield is 4.10555 multiplied by 100. So that will now be 3.8 divided by 4.1055 and multiplied by 100. So the percentage yield is, at least there are not a lot of errors here compared to 92.6%. So that's an approximated value. So the answer is 92.6%. So that is how to do it. So you know the actual yield. You will always supply the actual yield. Then you will be the one to calculate your theoretical yield. Then you find the percentage yield, and that's how to solve problems on percentage yield. So try the next question and leave your answer in the comment section. So try the next question and leave your answer in the comment section. If you have been with us for a while, please subscribe to our channel, encourage us. If you find the video helpful, please share with others. It might take a bit of time now because I really want you to get it right, and that's why we're going so slow. But we're still going to have a very fast class at a point in time. But let us all get this right first and make things count. So God bless you. I'll see you in the next class.